There are a number of ways to QC spectral inversion results. These include how well does the predicted interference pattern match the real interference pattern that you started with? Do the solutions match the layering seen at the well locations? When you look away from the well locations, is the 3D distribution or architecture of the predicted layering geologically sensible? When you band limit the predicted solution to the bandwidth of the input seismic data, how do the band limited forms compare? So for example, here we see a seismic cross-section that transects a well location. The seismic is in the form of colored inversion with approximately 5 to 40 Hz signal bandwidth. The colored inversion represents band-limited impedance. That means that the zero crossings represent band-limited, in other words, tuned interfaces. The target zone in this case is a soft sand represented by the red negative amplitudes. The well contains two sands. The upper sand is approximately 17 milliseconds thick. The lower sand is around 8 milliseconds thick, and the thickness of the shale break is approximately 5 milliseconds. When we applied spectral inversion on a trace-by-trace basis to this seismic zone of interest, the interference patterns consistently sensed and therefore predicted a two-layer solution. This corresponds nicely to what is seen at the well. Note the 10 millisecond scale bar for reference. The predicted thickness of the shale break is approximately the same order of magnitude as the 4 millisecond sample rate of the input data. Since the input data is colored inversion, which is a form of band-limited layering, we can then bandpass filter the layering representation that comes from the spectral inversion to match the bandwidth of the colored inversion input. The two band-limited forms can then be compared to determine how well they match.